In this video I have a little simple motor that I can make to demonstrate the motor effect out of using a few pieces of equipment that I've got sitting around the house. So here's a little wood screw that fell out of the wall the other day. Still got to fix that. And once hopefully the camera focuses soon, what I'm going to do is stick to that a little cylindrical magnet that my daughter has in one of her little magnet sets. Get in there. Okay, and so I've stuck a little magnet on the end there because the screw's got a fair bit of iron in it. It's attracted to the magnet, and then if I then just stick that on the end of um, a battery. So I've got a decent sized battery here, a C cell, so that it's got can provide quite a bit of current. What I'm going to do then, so you can see that the screw has become magnetized because it's stuck to the magnet, and it can now stick to the bottom of the battery. And just at the point though, so there's not much friction, which is good because I want it to spin. And I'm just going to get a little wire. I've got just a small piece of wire and stick that on the top of the just touch it onto the top of the battery, and then I'm going to touch the other end onto the side of the magnet, and we should see the motor effect. It should turn. So let's have a look. There we go. Spinning quite quickly. I believe I read somewhere that these can spin up to about 40,000 rotations per minute, RPMs. I don't know if it's this design or not. You can do other cool designs as well. This is just one example. You can actually get the wire to. There's one example I've done where you can make the wire go around the magnet, which is cool. I wish I don't have the right wire here to do it. There we go. So you can definitely see the motor effect must be acting on those bits of metal, both in the screw and the magnet, to make it rotate. So maybe we'll quickly draw a little diagram to see how that works. If I just turn the camera around. Okay, so then what I have is a small cylindrical magnet like that, and then it's stuck on the end of a screw. And there's the screw, something like that. It's got a thread on it. Okay, so I've just ruined it as a scientific diagram. I just drew in some 3D detail. Anyway, I shouldn't have done that. And then we have the battery. So, not to scale. Oh, that's terrible. Okay. Something like that, just quickly. And then I get a wire and I join that to there. So I know that the conventional current is actually going to flow down the wire that way from the positive end. So if I drew this as a circuit diagram, I've basically got, that would be my single cell DC power cell, or cell. That's the positive end, that's the negative end. Okay, and what's going to happen is that because these are both made of metal, there's going to be a current that flows up along the surface of these things in that direction. So basically, if I was to illustrate that, I'll just make it easy to see. There's basically a current flowing that way up the edge of those metal pieces. Now there's also a magnetic field from the magnet, and it'll be sort of looping around like this, coming out of the, I've just drawn one half of it. So there's, magnetic field lines on the other side as well. I've only drawn the ones on this side just to illustrate what's happening there. And let's imagine, I didn't notice what way it was. It'd be good I could look back at the video and see, but I didn't notice which way it was rotating. So let's imagine that the magnet here at the bottom rotated from the back of the magnet, came around on this side, and then went back around there. So let's imagine that the rotation was that way. Hopefully that makes it clear. From below, if I was to look at it from down here, that would be, so looking at it from there, that would be clockwise. So what that means is, if that's the case, then this is a current flowing in a magnetic field. So this edge of these metal objects here will experience the motor effect, and along this edge there's a magnetic field pointing to the left, probably, or to the right. It depends on which end's north and south. So let's imagine that if it rotated this way, I could actually tell which way this magnetic field is. So I have two choices. The force actually needs on this edge of this metal here has to be out of the page, upwards, for the according to my right hand grip palm rule, for it to rotate in the direction that's shown. So if I used like this version where this finger represents the force and this finger represents the magnetic field, that would actually tell me that for a force to be coming out of the page and there's a current with my thumb representing the conventional current up the page, that the field would have to actually be pointing to the left. So that means that these fields here are going like that. So that means that this is the north end up here with the magnetic field coming out of there, and this must be the south end. So I've been able to predict if this was the direction, and you could probably look on the video, and if it wasn't, then you can work it out the other way around. But so that's just a little example. It's not typical. It's not one that I've seen in an exam, but it's a common one because it's easy to make, that you see sort of on the internet or something on a video. And it was just a nice little example.